Hello and good afternoon friends, welcome once again to the CEC-UGC live lecture. Dear friends, as you know that from time to time we talk on different subjects and under these subjects we try to talk on different topics. So for the students of environmental sciences, we would like to tell you all that today we are going to talk on radiation and environment. We are going to discuss how harmful are these radiations to the environment which are caused or which are produced from the different sources, as well as we would be discussing what are the parameters of measurement of these radiations emerged out of various sources, as well as what could be done so that we can save our environment from these harmful radiations. So for this, dear friends, today we have with us in our studios Dr. Arun Kumar Srivastav. Dr. Arun Kumar is Assistant Professor in School of Environmental Sciences in Jawaharlal Nehru University. So first of all, I would like to welcome our guest, Dr. Arun Kumar Srivastav, and under his able guidance, today we are going to study the very topic radiations and environment, that is how radiations affect the environment. Hello sir, welcome to the reset lecture. As the topic itself suggests, the radiation and environment, which simply means that radiations has ill effect on environment. So through you we want to understand how radiation cause the ill effects on the environment. So over to you sir.
Thank you very much. Good afternoon friends. Today we will discuss a very important topic, that is radiation and environment. Whenever we speak about environment and environmental pollution, we generally talk about air pollution, water pollution, soil pollution, noise pollution, etc. because these are the pollutions which we encounter every day. But there is one kind of threat which we never give more attention, or the attention it required, that is radiation. In fact, radiation is an essential part for our life, without which our life can't flourish and we can't go ahead in our life. But sometimes radiation may cause very ill effects as far as our health, as far as our general environment is concerned. So today we will discuss this topic, radiation and environment. Starting from radiation, what is radiation exactly? In fact, radiation is a kind of energy. It is in the form of waves or particles, and it can come from a source and may travel through some material or through space, like light, heat, sounds. All these are type of radiations. The kind of radiation which we will discuss in this presentation or in this topic is mainly ionization radiation. We will discuss what is ionization radiation and what is non-ionizing radiation later on. So starting again, so going through the radiation. Radiation is, it can be divided into three different parts, that is electromagnetic radiation, particle radiation and acoustic radiation. These are three types of different radiations. So starting from electromagnetic radiation, what is electromagnetic radiation? It can be either radio waves, visible light or X-rays, which are having the characteristic of particle as well as of wave nature. The second one is particle radiation. Particle radiation could be alpha particles, beta particles or neutron particles. Third one is acoustic radiation. Acoustic radiation, or which is as its name suggests, it must have come from various sources of sound. It could be ultrasound, general sound or seismic sound waves. So radiations are generally of three types: electromagnetic radiation, particle radiation and acoustic radiation, as far as its nature and its composition is concerned. So here in this picture we have given the detailed different components of electromagnetic radiation. Electromagnetic radiation might start, as far as wavelength is concerned, from 0.1 angstrom to up to 1 kilometer. So the spectrum or the range is very, very broad. It is from 0.1 angstrom, angstrom is 10 to the power minus 10 meter as we all know, to over 1 kilometer or 1000 meters. And in this electromagnetic radiation, it is comprised of gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwaves, radio and television waves, as well as long waves. But as far as our radiation, about which we will be discussing today, is concerned, it is covered in the lower wavelength portion. I mean, it might be in the gamma rays or X-rays or ultraviolet rays or somehow the visible and infrared rays. So, as far as this characterization according to its ionizing or non-ionization character is concerned, it might be divided into two different categories, that is ionizing radiation and non-ionizing radiation. Ionizing radiation may be alpha particles, beta particles, photons and neutrons. Non-ionizing radiation could be ultraviolet rays, visible rays, infrared rays, microwave as well as radio waves. As far as our topic of discussion is concerned today, we will be discussing or we will be concentrating more on ionizing radiation. However, we will put some light on non-ionizing radiation too. So, what is starting from non-ionizing radiation? What is non-ionizing radiation? Non-ionizing radiation may be defined as any type of electromagnetic radiation that does not carry enough energy per quantum to ionize atoms or molecules, that is to completely remove. Ionizing character is basically to remove the electrons from the atom or molecules from its outermost orbital. So, we can say non-ionizing radiation is not capable of removing the electrons from an atom or from a molecule. So, it can't ionize an atom or molecule. As far as ionizing radiation is concerned, ionizing radiation is basically a radiation that carries enough energy to liberate electrons from atoms or molecules, thereby ionizing them. It means ionizing radiation is a type of radiation which have the capability or capacity to ionize the atoms or molecules and to make it an ion, whether it is a positive ion or a negative ion. Similarly, ionizing radiation is composed of energetic subatomic particles, ions or atoms, moving at relativistic high speeds and electromagnetic waves on the high energy end of the electromagnetic spectrum. We can say in the previous slides we saw the spectrum of electromagnetic radiation. So, the components of that electromagnetic spectrum which is at the higher energy side or with the lower wavelengths, they come into this category and they are capable to ionize the atoms or molecules. Ionizing and non-ionizing radiation, as far as combined characters are concerned, it is in fact it falls in the region at which radiation considered as ionizing is not well defined, since different molecules and atoms ionize at different energies. So, we can't say, if we take into consideration the spectrum which we saw just now, that where exactly from where the ionizing radiation starts and ends and from where the non-ionizing radiation starts and ends, because the radiation are having different energies level as far as its ionizing capacities are concerned. Similarly, we can say that gamma rays, X-rays and the higher ultraviolet parts of the electromagnetic spectrum are having the capacity to ionize the atoms or molecules. So, they come into the category of ionizing radiation, while the lower ultraviolet part of the electromagnetic spectrum, which from there lower electromagnetic part of the UV spectrum, the visible lights, infrared and microwave or radio waves etc., they come into the category of non-ionizing radiation. So, we should go back again to the spectrum of electromagnetic radiation. Here we see the ultraviolet ray, which is third from the top, and its wavelength range is between 10 nanometer to 100 nanometer. So, this ultraviolet exactly, and we can't say this, the boundary of ionization radiation and non-ionization radiation is very sharp. From here somewhere the ionizing characteristic starts. So, from ultraviolets that point to above, as far as energies are concerned or the lower wavelengths are concerned, if we go up towards the X-rays or gamma rays, there the ionizing radiations are, and if we go below or towards the lower energy side from ultraviolet rays, which is visible light, infrared, microwaves, radio waves and long waves, they are non-ionizing radiations. It has further been clarified that the boundary between ionizing and non-ionizing electromagnetic radiation are not sharply defined, since different molecules and atoms ionize at different energies. So, and conventionally we have placed the boundary somewhere between 10 electron volt and 33 electron volt. Somewhere between these two, the ionizing and non-ionizing characteristics of electromagnetic radiations are characteristics of electromagnetic radiation lie. Here again the same thing is there. We can see here the somewhere the boundary is very diffused. The ionizing and non-ionizing characteristics of electromagnetic radiations are there. Here we will see that the UV rays, some portions of the UV rays and X-rays, gamma rays come into the category of ionizing radiations, while the radio, microwave, infrared, thermal infrared or non-thermal infrared, visible light, etc., they come into the non-ionizing radiation categories. Now we will discuss mainly on ionizing radiation now. So, what is ionizing radiation? As far as other characteristics are concerned, ionizing radiation is invisible and not directly detectable by human senses. So, radiation detection instruments such as Geiger-Müller counters, etc., are required for its detection and measurements. However, ionizing radiation may lead to secondary emission of visible light upon interaction with matter. It means although it is totally invisible, we can't see it by our bare eyes, but sometimes what happens, this ionizing radiation, whenever it falls on some material, it might generate the visible light which is visible. Now again the ionizing radiation, there are mainly 4 types of different ionizing radiations about which we will be concerned. They are alpha particles, beta particles, photon radiation and neutron radiation. And here alpha particle is basically a positively charged particles having 2 protons, while beta particle is a negatively charged particle, while neutron radiation, they do not carry any kind of charge, they are neutral. As far as photon radiations are concerned, they are mainly of 2 types, one is gamma rays, another is X-rays. And we all know what is X-ray. X-ray is basically a kind of secondary rays, and when it how it is generated, whenever a cathode rays or electrons fall upon any metal surface, it gives rise to a secondary kind of rays. They are known as X-rays. However, X-rays are very important as far as medical sciences is concerned. Now, discussing one by one, alpha radiation. What is alpha radiation? Basically, this alpha radiation is mainly of particulate nature. This is not of wave nature, but of particulate nature. Alpha particles consist of 2 protons and 2 neutrons, and they are bound together into a particle form, and which is more or less identical to the nucleus of helium. The only difference between the nucleus of helium and alpha particle is that alpha particles do not contain electrons, 2 electrons, which is there in the helium atom. And alpha particles emission are generally produced in the process of alpha decay, but may also be produced in other ways also. Since they are identical to helium nuclei, they are also sometimes written as He2 plus or 2,4 He2 plus, which indicate a helium ion with plus 2 charge. I mean, it means that it is this alpha particle is basically the helium atom, but it is without the 2 electrons which should be present there. I mean, it is it has lost its 2 electrons. Again, in continuation with the alpha radiation, alpha particles are highly ionizing form of particle radiation, and when they result from radioactive alpha decay, they have low penetration depth. They also can be stopped by a few centimeters of air or by the skin. The helium nuclei that forms 10 to 20% of cosmic rays are also usually of much higher energy than those produced by nuclear decay processes, and are thus able to traverse the human body and dense shielding. As far as penetration capacity is concerned, we will discuss later on in detail with all the different ionizing radiations. Here I must say that alpha radiation, although they are ionizing kind of radiation, but as far as their penetration capacity is concerned, they can't penetrate much. They can be stopped by a simple aluminum foil or simple metal, and it can also be stopped by the skin. They are not capable of penetrating through the skin. But as far as beta particles are concerned, they have more energy than alpha particles, and their speed is also higher than that of alpha particle. I mean, it can penetrate further more than that of alpha particles. The production of beta particle is known as beta decay. There are in fact two forms of beta decay, beta minus and beta plus, which respectively give rise to the electron and positron. I mean, beta can be decay either in the form of beta minus or beta plus. When it decays in the form of beta minus, it gives rise to the electrons, and whenever it decays in the form of beta plus, it gives rise to positron. Now, photon radiation. In fact, the third one, the photon radiation, although photons are electrically neutral, they can ionize atom directly through the photoelectric effect. Photoelectric effect, we all know that whenever photon strikes on any surface, a current might be generated. How the current is generated? Because electron is dislodged from the atoms or molecules of that particular metal. This interaction may cause the ejection of an electron from an atom, turning that electron into a beta particle, and in fact that is known as secondary beta particle that can ionize many other atoms. Once the electrons or beta particles are dislodged from the atom, this secondary beta particle or the secondary particle which has been generated now is capable to ionize many other atoms or many other adjacent atoms. So, it means that photon radiation itself is capable of ionizing by itself, and apart from that it can produce the ionizing effect also. First it ionizes, and second the ionizing particles which have been ionized particles which are generated, they are capable to produce the secondary kind of ionizations. Since most of the affected atoms are ionized directly by the secondary beta particles, photon are also known as indirectly ionizing radiation. So, it has both the capabilities, it can have direct ionizing capabilities as well as it can have indirect or secondary ionizing capabilities. Now, photon radiation is called gamma rays. In fact, I discussed there are two types of photon radiation. One is gamma rays, another is X-rays. So, photon radiation is called gamma rays if produced by nuclear reaction, subatomic particle decay or radioactive decay within the nucleus. So, when photon ionizes any kind of nuclear material or subatomic particle or radioactive particles, the decay which is the decay product which is made is gamma rays. In fact, gamma rays is highly energetic and have high penetration capacity. It is otherwise, this photon is otherwise the second type of its radiation is X-ray, and how it is produced when it affects outside the nucleus, then the X-rays are produced. The generic term photon is therefore used to describe both. I mean, photon can be used to describe both X-rays as well as gamma rays. Now, we will discuss gamma rays and X-rays in little detail. What is gamma rays? These are basically electromagnetic radiation of an extremely high frequency, and therefore, it is consist of high energy photons. Gamma rays are ionizing radiation and are thus therefore, they are biologically very hazardous. They are classically produced by the decay of atomic nuclei as they transition from a high energy state to lower state known as gamma radiation. In fact, what happens, the photons whenever they strike on any material, let it be radioactive materials, the atoms they go into the higher energy level, and from that higher energy level, whenever that atom comes back to its normal or the lower energy level, it emits a very good amount of energy in the form of rays, and that is they are basically the gamma rays, and they are highly energetic particle having a very high penetration capabilities. The next one is X-rays. What is X-rays? X-rays is a form of electromagnetic radiation. Most X-rays have a wavelength ranging from 0.01 to 10 nanometers, corresponding to the energies in the range of 100 electron volt to 1 lakh electron volt. So, the energy range of X-rays are very variable. It has a very high range of energies. So, we can say as far as this energies and its penetration capacities are concerned, they are also variable, and it depends how these X-rays are and in what conditions these X-rays are produced. And that is why X-rays have got a very wide range of applications because of its wide range of energy carrying capacities. So, X-rays wavelength are shorter than those of UV rays and typically longer than those of gamma rays. We can say this is why the X-rays fall between UV rays and gamma rays, because its wavelength are higher than gamma rays, but lower than UV rays. X-ray photons carry enough energy to ionize atoms and disrupt molecular bonds. This makes it a typical type of ionizing radiation and therefore harmful, very harmful in fact sometimes to living tissues. A very high radiation dose over a short span of time might cause radiation sickness, while lower dose can give an increased risk of radiation induced cancer. Here the lower dose means lower dose for a prolonged duration. The last one is neutron radiation. What are neutron radiations? Neutron radiations basically consist of free neutrons. They are totally neutral. I mean, they don't have any kind of charge, whether it is positive or negative. These neutrons may be emitted during nuclear fissions. There are two types of neutrons, such as thermal neutrons. These thermal neutrons are also known as slow neutrons and fast neutrons, depending upon their energy. So, I must say here that neutrons are not generally found like anything, but they are produced in specific situations, specific conditions, and they are generally produced during nuclear fissions. As far as their penetration capacity in total are concerned, neutrons penetration capacity is highest. Neutrons are rare radioactive particles. They result in fact in large amount only where chain reactions, it could be fission or fusion, are active. Neutrons are the only type of ionizing radiations that can make other objects or material radioactive. It means that neutrons, once it is produced from any kind of material, if it is even non-radioactive, or it is, I mean, in that kind of category, radioactive material category, but presently that particular isotope is non-radioactive, but once the neutron strikes, it changes into into another isotope, and that isotope might be radioactive. So, we can say here that neutrons have high energy and ionizing capacities, and it can make other materials or objects radioactive. Now, here in this particular picture, we will see the penetration capacities of different radiations. Here in total given alpha, beta, gamma, alpha, beta, X-rays, gamma and neutrons. Here we can see here that alpha particles can be stopped very efficiently by paper, or even whenever it strikes with skin, whatever the energy carrying capacity of that alpha particle could be, but it can't cross the skin. So, it can very efficiently be stopped by either paper or skin. So, whenever there is a possibility of alpha particle radiation, we can stop it by a simple clothing. If we have a simple ordinary proper clothing, these alpha particles can be stopped and we do not have to much worry. But as far as beta particles are concerned, it can efficiently cross the paper and it can go into the skin, or it can cross through sometimes, although it is very rare, it can cross through the skin. So, it can penetrate deep into the skin, but the chances of beta particles of crossing the skin and reaching the other vital parts of our body is very, very less. So, if we have some specific kind of protective clothing, I mean they are designed for stopping the beta particles can be stopped. So, whenever there is a probability of beta particles presence, we are advised to wear the proper and recommended clothing, because it can't be stopped with the help of normal clothing. And the third one is X-rays. X-rays are comparatively more energetic than that of alpha, beta and alpha beta particles. It can efficiently cross paper as well as it can efficiently cross skin. However, one more thing I would like to say here, that it has the capability of crossing even wood. So, X-rays are capable of crossing paper, skin as well as wood. So, whenever there is a probability of X-rays, or whenever we are in a region where the presence of X-rays are there, we are advised not to go there, and if we are anyhow will have to go there, we must have a recommended and specified clothing to go in that region. And the type of thing which can stop X-rays or cement or concrete. So, X-rays can efficiently be stopped by concrete. So, whenever there is a X-ray operation or there is a possibility of X-ray generation, it should be in a very closed vessel or closed or in an enclosure, and that enclosure should be of cement or concrete. The next one is gamma rays. Gamma rays have energies more than that of alpha, beta and X-rays. So, this gamma can efficiently cross paper, it can efficiently cross skin, it can efficiently cross wood, and even it can go into the cement or concrete blocks. However, the chances if that concrete block is efficient or good, so it can be stopped. I mean it can't be reflected back by the concrete block, but it can efficiently be absorbed by the concrete block. So, in case of whenever there is a operation of gamma radiation, or there is chances of presence of gamma radiation, it should be protected, it can be protected efficiently with the help of concrete or cement blocks. As far as neutrons are concerned, neutrons in general can't be stopped by anything, whether it is paper, skin, wood or cement. It can efficiently cross anything. So, even it can cross the strong and hard concrete blocks. So, whenever however, fortunately the occurrence or the presence of neutrons are very, very less in comparison to other radiation particles or radiation parts. As far as detection of radiation is concerned, I told in the beginning that radiation can't be detected or sensed by the human eyes or human senses. For detecting and sensing radiation, we are supposed to have a variety of instruments. Now, what those instruments which can detect and which can monitor or measure the radiation based on? They are mainly based on energy, position and how much. I mean, whenever we will have to detect a radiation, we will have to attack on three different things. One is energy, I mean how much energy it is emitting, because with the help of that energy only we can identify what type of radiation is that, whether it is alpha, whether it is beta, gamma, X-rays or neutron, and its position, I mean from where exactly it is coming. And the third one is how much or how many. Sometimes whenever it is in the form of particle nature, we will have to see how many, I mean how many particles are present, and whenever it is in the form of wave nature, then we will have to measure it in the terms of how much, I mean how much waves of that particular radiation are present. So, we will have to attack, or we will have to concentrate us on three things. One is energy, position and how much or how many. Now, the size or weight of radioactive material does not indicate how much radioactive it is. It means that if there is a bigger size of radioactive material and there is a smaller size of radioactive material, it does not mean that bigger size of radioactive material will be more radioactive and will emit more radiation than that of a smaller one. Sometimes the reverse might be true. So, the amount of radioactivity in a quantity or material can be determined by noting how many curies of the material are present. I mean whether it is a big size radioactive material or smaller size radioactive material, size does not matter. We will have to check how much curies it contains. For example, uranium-238 has 0.00015 curies of radioactivity per pound. I mean it can be also said that it has 1 pound of uranium-238 has 0.15 millicuries, while cobalt-60 has 518,000 curies per pound. So, we can see here how big the difference is. The difference is in millions times of same 1 pound radioactive material. One is uranium-238, another is cobalt-60. Now, what are the different units for measurement of radiation? They are curie, rad, rem and Roentgen. As far as common units are concerned, they are becquerel, Gray, Sievert, coulomb per kilogram as far as in SI units. So, in fact, these units are required for different things of radiation. One is absorbed dose, and this absorbed dose is measured in rad. So, what is absorbed dose? Absorbed dose is basically a physical quantity representing the mean energy imparted to matter per unit mass by ionizing radiation. It means that whenever a radioactive material is present, how much it is emitting from, how much emission is taking from that radioactive materials, it is measured in curie. And whenever it is absorbed by something, I mean whenever it goes or penetrate into someone's body, that it might be, then it might be imparting some energy to the body per unit mass, and that per unit mass energy imparted is known as absorbed dose, and it is measured in rad in the common units, or it is measured in Gray in SI units. And the next one is dose equivalent. What is dose? It is also known as effective dose. What is dose equivalent exactly? Dose equivalent, actually it combines the amount of radiation which is absorbed and the medical effect of that type of radiation. I mean once the energy is imparted to the body or skin or any vital part of the body, and this medical effect, I mean the outcome or the later on effect which is generated after the radiation exposure is known as dose equivalent. Dose equivalents are in fact very important as far as radiations are concerned, and they are measured in rem in common units as well as sievert in SI units. The last one is exposure, which actually describes the amount of radiation traveling through air. it is general term, and this is measured in Roentgen as far as common units are concerned, and it is measured in coulombs per kilogram as far as SI units are concerned. Now, how it is detected? So, as far as its detections are concerned, these detections are based on different 4 type of things. One is counters, I mean it generally counts the number of particles, whether it is alpha or beta are present, and this counter actually is based on number of interaction with any base material, and that interaction gives rise to pulses, and this pulse and interaction basically is able to count the number of particles. It is a very simple and general principle. And the second one is spectrometer, and this spectrometer is basically is based on the interaction of energy with that particular specific type of materials. This again gives the information in the pulse mode. And the third one is dosimeter, and in fact the dosimeter is basically is based on the net amount of energy which is deposited, and the result comes in the form of current mode. And finally, the imaging system, whether it is current mode or pulse mode, is finally able to give you the result or the required information. Now, how many types of detectors are there? Because here we will discuss mainly on detectors. There are generally 4 type of detectors. One is gas-filled detector, the next one is solid filled, or it is also known as semiconductor detectors. The third one is organic scintillators. They could be liquid or plastic. The basic materials could be liquid or plastic. And the fourth one is inorganic scintillators. Now, discussing one by one, what are gas-filled detectors? So, here a schematic diagram of the gas-filled detectors as well as the instruments are given. To our left side, the schematic of or the you can say the outline or the principled outline of the gas-filled detector is given. So, here in this actually electrical charge liberated by ionization radiation is collected by positive and negative electrodes, and the example of such type of instruments are Geiger-Müller. Here we can see the ionizing radiation is falling on that cylindrical tube on the right hand side of that cylindrical tube. Cylindrical tube is basically it contains cathode as well as anode. Whenever, and that cylindrical tube is containing a specific kind of gas. Whenever the ionizing radiation falls on that tube, or in fact that gas gets ionized and ion is produced. Whenever that ion is produced, electric pulses are generated, and that goes through the through the electric circuit to a counter, and this is how the counting is done. So, this is the basic principle of Geiger-Müller counter. To our right hand side, the instrument of the instrument which is known as Geiger-Müller counter is given. The next one is solid state or semiconductor device. So, this the basic principle or the working principle of this semiconductor device is more or less same as that of gas-filled device, but here the only difference is that here instead of that gas, a semiconductor material is there. So, whenever the ionizing radiation falls on that semiconductor material, a hole and electron, I mean a pair of hole and electrons are produced, and that hole and electrons while traveling is capable of producing electrical pulses, and that electrical pulses can be utilized for the counting. The next one is organic, liquid and plastic scintillators. So, here in this particular instrument what happens, a scintillation counter is first we will define what is scintillation counter. A scintillation counter is an instrument for detecting and measuring ionizing radiation by using the excitation effect of incident radiation on the scintillator material and detecting the resultant light pulses. So, here what happens actually, the radiation falls on on a crystal that is basically sodium iodide crystal. That crystal is joined by photocathode and optical window. So, what happens once the radiation falls on that sodium iodide crystal, that crystal actually emits the light waves, and that light waves falls on any kind of photomultiplier tube, and after multiplication, because initially that light is very, as far as intensity is concerned, very less, it is so extremely less that it can't be measured easily. So, a photomultiplier tube is needed, and with the help of that photomultiplier tube, that very small quantity of light which is generated in the beginning is converted into full light, and that light is measured by a measuring device, and then we estimate, we can with the help of that final light, we can estimate the exact amount of radiation. To our right hand side, the instrument, the full instrument is given. The third one is inorganic scintillator. Here what happens, radiation actually the ionizing radiation lifts electrons from the valency bond and it reaches to the conduction band, and this difference of energy level which is generated here, whenever it comes to the normal level, a light is emitted, and this light again with the help of photomultiplier is measured, and that measured light might give the information about the radiation which has fallen in the beginning. Here the basic radiation detector systems principle is given. We can see here the radiation first falls on the detector, and detector could be anything, it could be organic compound, inorganic compound, gas, semiconductor device or anything else, and from there it goes to signal mode, and this signal could be either pulse or in the form of current, and that pulse or current is amplified, and that amplified pulse or current goes to the analog system, and from analog it is converted into digital, and from digital it is stored to disk or it is retrieved. So, with the help of this, I think the first part of this radiation about radiation is finished, and we will discuss later the remaining part, I mean its sources, its effect, how it is detected, and once it is detected that there are radiations present, and what protective measures can be taken.
So we have talked a lot about the harmful effects of the radiations on the environment, as well as we discussed how there are different processes with the help of which the radiations in the environment could be measured. Now the question arises, when we are talking about the harmful effects of radiations, what are the ill effects on the point of view if we talk about the health issues? Are these radiations harmful for health?
Radiations are very harmful. I mean it's extremely harmful, and in fact its effect etc. we will discuss in detail tomorrow or in the next session. So, but in short I must say that radiations are extremely harmful depending upon what is the nature of that radiation. As I discussed, there are mainly 4 types of radiations: alpha, beta, photon and neutron radiation. Alpha is not very harmful if it is one is not exposed for a very prolonged period. If one is exposed for a shorter duration, it might not cause much ill effects, but as far as beta, gamma etc. are concerned, as well as X-rays are concerned, they are very harmful, if sometimes even in a very smaller quantity and for a very shorter duration. So, and as far as the kind of effects are concerned, it can give short term diseases, I mean some very temporary diseases, to long term diseases which could be chronic. I mean even radiations are established carcinogen. Radiations are known to have cancerous effect or health effect which are irreversible.
Because the human part or human body is very sensitive, for example skin and eyes, and we could see and we could make out from the diseases which are occurring all because of the environment, that is the skin diseases are more all because of the environment. Does these radiations affects the skin portion of the body?
Yes, I mean I told beta is capable to somehow go not deep into the skin, but it can be lodged into the skin. So, if someone is exposed with beta particles for a longer duration and is is taking out is not possible, somehow it is there for a very prolonged period. So, the chances are there the skin can be severely affected depending upon the immunity of that person. If the person is not, his immunity is not very strong, then the possibilities of some permanent diseases are very much. And as far as gamma or X-rays are concerned, they are capable of lodging as well as crossing the skins. So, these radiations can cross easily the skin, and even it can attack the vital organs of our body, as far as bones, other organs like kidneys, heart, lungs, other tissues, etc. are concerned. So, these radiations not only skin as well as it can affect very efficiently, it can affect to the other vital organs of human body.
So, there is one question appearing into my mind, can heating cause radiation? Does the wastage which we sometimes have in our houses
yes.
Can produce radiations?
Radiation. I told in the beginning that there are two types of radiation, one is ionizing radiation and another is non-ionizing radiation. So, heating etc., even visible light, whatever we have every day, we encounter huge amount of and regularly we encounter radiations, but fortunately these radiations are not of ionizing nature, they are mainly of non-ionizing radiations. So, the lethal effect or the fatal effect is mainly caused by ionizing radiation, not by non-ionizing radiation. So, we are safe because mostly we encounter with non-ionizing radiation, whether it is in the form of light, whether it is in the form of heat, whether it is naturally or it is artificially generated. So, mostly we encounter with the non-ionizing radiation. So, we are fortunately safe, but whenever we encounter ionizing radiation, the sources could be sometimes natural, as well as the building materials also contains the ionizing radiation. Apart from that, medical wastes, the major concern is medical applications and medical wastes, they generally have some ionizing radiations, and whenever we will encounter, fortunately or unfortunately with the ionizing radiation, that can have ill health effects.
As you talked about the medical wastage, for example, the wrappers we have produced or we got after taking out the medicine, does they also produce the radiations?
No, they generally do. In fact, radiations are used in medical science by curing many other things, for treatment of many other diseases like thyroid glands etc. They are nowadays very common medical problems. For these applications, radiations are utilized, ionizing radiations. So, these ionizing radiations, whenever they are not handled properly, either to the patients or by the operator, the person who is handling it, if it is not handled properly, and it crosses the stipulated limit, so it might have ill health effect either to the operator or to the patient or the persons who are present nearby.
That is, the care should be taken while dealing with the patients,
yes,
both
definitely.
To the doctor as well as patients, so that
yes,
the other portion of the body could
because
not
recently
be
we heard in news there was a cargo at IGI and there was some leakage. That medical based the medical appliance were in fact destined to some hospital, some popular hospital of Delhi, and there was a leakage. So, fortunately, it was found that it was not emitting any harmful radiation, but if it would have been, then it could have been very harmful to the persons who are employed there or who might have been working with those kind of cargo.
Sir, what about the factories or the places where nuclear tests are carried out? Should they be away from the cities or?
Yes, in fact, that is why they are mostly kept far away from the human population as far as the nuclear tests are concerned. But the power plants, those power plants which are based on nuclear energy, atomic power plant, they are not far off from the cities, and in fact, because they can't be, because the electricity they are producing, it has to be supplied to that particular city. So, there they must follow, in fact, they will be following the prescribed precautions which they are supposed to, because if it is not done, it can be very, very harmful. And this is why this was the problem in the beginning when this nuclear radiation etc. were invented, either for nuclear test purposes or bomb purposes or power generation purposes. The precautions were not taken as it was supposed to be, and that caused many health effects or many worst effects.
So, is there any protocol for all the factories
Yes,
or the power plants?
There are number of protocols, and in fact they are following. If they don't follow, the things could be worse. In fact, all these we'll discuss in the next session.
Definitely, we are going to discuss all these points which we are talking about in our next lecture, that would be tomorrow, and we would be discussing more on radiation and environment. With this note, dear friends, I would like to tell you all that if you have any queries or if you want to give your feedback regarding this particular lecture, or if you want to have a lecture on a particular topic, then you can mail us at info.cec@nic.in. We would love to take your questions, and the next time, definitely tomorrow, when Dr. Arun Srivastava visits our studio, we would love to solve your queries, your questions. And dear friends, if you wish to access this lecture, you can access it with the help of YouTube. As we daily say that we upload these lectures for you, so that it becomes convenient for you to access these lectures, to see these lectures ample of time, and it becomes convenient for you to study the course material with the help of these lectures. With this note, thank you, sir. Thank you so very much for giving your precious time. Thank you.